Hello guys, welcome back to my channel. Now today we're going to be looking at a fun and easy way to multiply numbers using lines. Now this method can either be credited to the Japanese or the Chinese, but the origin of this method is not exactly known. So let us get right into it. Let us say that we have 21 multiplied by 12. We represent the 21 by drawing two lines, skipping a and we draw a next line. So the two lines that are closed, that is for the 2 and the 1 is this line here. To represent the 12, we draw one line and then we skip a space and we draw another two lines going in the opposite direction. Okay, so what is 21 times 12? We have several things labeled here. This is my ones position, this is my tens position, and over here we have our 100 position. Now, what we do to get the answer to this is to count the amount of intersections that we have. Now, in the ones position, we have two intersections. In the tens position, which is all of the middle, all of this section here, we have 1, 2, 3, 4, 5. We have 5 intersections. And in the 100 positions, we have 2 intersections. So the answer to 21 times 12 is 252. Let us look at a second example, 32 multiplied by 25. So for 32, we're going to have three lines. 1, 2, 3. We're going to skip a space and we're going to have two lines. So 1, 2. Now for 25, we're going to go the opposite direction. So we're going to have two lines. 1, 2. And then for the 5, we're going to have 5 lines here. So we skip a space and we're going to have 1, 2, 3, 4, 5 lines. Now remember, to the right we have our ones position. So let us count off the intersections. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 intersections there. So this is what we do. We're going to put a 0 here and we're going to carry the 1 to the middle. So let us count off the amount of intersections we have in the middle. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. And bear in mind that we have an additional 1 here that came from the 1 position. So we have 20. So we're going to put a 0 here and we're going to carry the 2 up here. So let us count off the intersections over here. Now we have 1, 2, 3, 4, 5, 6. And bear in mind that we have this additional 2, so it would be 2 plus 6, which would give me 8. So the answer to this question is 800. Now let us say we had 20 multiplied by 12. What would be unique here would be the 0, because there would be no line for 0. So what I'm going to have to do when drawing something to represent 0, I'm going to have to change the color of the line. So for 20, I'm going to have two lines, 1, 2, and I'm going to skip a space and I'm going to use a different color for 0. So we're going to have a red line to represent 0. Now for 12, bear in mind that we are going the opposite direction now. So I'm going to have one line for 1, I'm going to skip a space and I'm going to have two lines for 2. 1, 2. Now bear in mind that this is our ones position, but because the 0 line intersects here, I'm not going to count any of the intersection with the 0 line. So here I'm just going to have 0. In the middle here, where is where we get to our tens, bear in mind that the 0 line doesn't count. So this intersection of blue and red here wouldn't count because of my 0 line, which is red. So in the middle, technically I only have 1, 2, 3, 4 intersections. So I have 4 here. And in the hundreds position, we have 1, 2 legal intersections. So we have 2 there. So my answer of 20 times 12 is 240. This method is even powerful enough to expand algebraic brackets. So for x plus y, the only thing here is that I'm going to be using a different color for x and a different color for y. So I'm going to be using blue for x. So because we have one x, I'm going to have one blue line going that way. I also have one y, so I'm going to be using red, and I'm going to have another line going that direction as well. For my second bracket, I'm however going to change direction, and notice that we have x plus 2y. The x there is blue, so we're going to have one blue line going the opposite direction. So this is my x right there. Now for 2y, y is red, so we're going to have two lines going the opposite direction. So we have two red lines like this. Now, this is what happens in this particular scenario. Down here in this position, because we have strictly y lines crossing, we're going to end up with y squared, because bear in mind that the red lines represent the square term. The red lines represent the y term. And because we have red lines intersecting, we're going to have squared there. So what we actually have here is 2y squared. In the middle, we have red and blue intersecting. So it's a combination of x and y. So we have 1, 2, 3. So what we're going to have is 3xy here. To the far left here, we have one intersection, but the two lines are blue. So that is going to give me an x squared. So when I expand this bracket, it's going to be equivalent to x squared plus 3xy plus 2y squared. Very effective method indeed. Credit must be given to either the Japanese or the Chinese who are devising this method.